Hey guys, so today we're going to have a video about how to graph inverse sine and inverse cosine. And the first thing I want to go over is just what an inverse is. An inverse has to be a one-to-one function, meaning it has to pass the horizontal line test of the original function. The original function, I should say, has to pass the horizontal line test. Sorry if that's not a very good sine graph. We should draw it first, though, before we get into inverses, because one-to-one means that it has to pass the horizontal line test, like I said, which means that every time I should be able to draw a horizontal line through it, and it should only touch the graph at one point. As you can see, this is not true. This part touches here, it touches here, touches here, touches here, and it could just touch infinitely more times as the graph went on. So we can't do that. And then another thing that we need, so we're going to have to change something with that. And another thing that we need to know is that when we take an inverse, the x's and y's swap. So for example, in a normal sine function, the y's range from -1 all the way up to 1. So y goes from -1 to 1. So now an inverse sine, x is going to range from -1 to 1. So we can put that in right here, -1 to 1. Then also, in this similar thing, we have x's and y swap. So now our x's, x of the original sine function, well, first we need to restrict our domain. So let's do that now. So we need to make it to where we can draw a line through it at any horizontal, and it's only going to pass at one point. So obviously from 0 to 2 pi, it doesn't work like that. But how about from pi, starting at pi over 2, when it's negative pi over 2, -1, that point, if we go just all the way up to pi over 2, 1, that's going to pass the horizontal line test. So let's restrict our domain. Pretend none of this is here. We're changing the domain. This doesn't exist. This doesn't exist. Now you can see, okay, it passes the horizontal line test. Look, draw a horizontal line, only goes through once. So domain has been restricted to negative pi over 2 to pi over 2. So that means that the y's in the inverse function are going to range from negative pi over 2 to pi over 2. So now we can put those in. We've got our major points ready. Now we just need to think about how to graph it. So what we can do is we can take points from this sine function and then just swap the x's and y's and graph them here. So a way to do that is we'll start at the bottom. We've got the point negative pi over 2, -1. We're going to swap the x's and y's, so that becomes, for the inverse function, -1, negative pi over 2. -1, negative pi over 2. It's a point right here. Sounds good to me. Okay, and then now we have the point, another important one, 0, 0. If we swap x's and y's, we get 0, 0. Nothing changes there. Goes to the origin. I've already got that labeled. Okay, so a final important point we can say is pi over 2. And then it goes at 1. And that becomes, if we swap the x's and y's, we get 1 pi over 2. Let's graph that 1 pi over 2. And then now connect it a little bit wavy like sine always is. It goes like this, and it's going to go up. And that's our inverse function. So it passes the horizontal line test. We've swapped the x's and y's, and that's all we have to do. I know it can be confusing. Just remember that it does not extend infinitely, like it doesn't do this and then this. It's not like your other trig functions where that happens. The domain of, I may as well rewrite this, domain of inverse sine goes from -1 to 1. The range of inverse sine goes from negative pi over 2 to pi over 2. If you know that, and you know that it goes up, yeah, it does go up, you'll be fine. And notice here that the sine function is going upwards from negative pi over 2 to pi over 2, so it kind of makes sense that this is also increasing along negative pi over 2 to pi over 2. So now that's inverse sine. Let's get into inverse cosine right here. Again, we run into the same problems where we've got to get this domain to where it can pass the horizontal line test, because notice we can draw a line here. It touches the graph many times. It's not going to pass the test. So we need to restrict the domain. And here we like to start at 0. Then think about it. It has to go all the way down, and it can't come back up, because as soon as it does, it wouldn't pass the horizontal line test. So we can go all the way from 0 all the way to pi. then we're restricting our domain, so none of this stuff is part of our graph anymore, none of this stuff. And so now what we've done is we've made the x's of the original have become 0 to pi. So that means that the y's of the inverse are going to be 0 to pi. And now let's think the y's of the original, I wrote y squared. The y's of the original are from 1, or -1 to 1, I should say. So now your x's of the inverse are going to go from -1 to 1. So similar to sine, except now instead of going -pi/2 to pi/2, we're going from 0 to pi in the range. So 0 to pi, and -1 and 1, just like sine. Alright, so now we can just take our points, the important points. We've got 1 in the cosine function as 0, 1. Going to swap those x's and y's, so we're going to be at 1, 0. And then we can take the point pi/2, 0. That's this one right here. And swap those around, and we're going to get 0, pi/2. So we've got 1, 0 there. We've got 0, pi/2 right here. Then we've got a final critical point at pi, -1. And take the inverse, swap the values. We're going to be at -1, pi. So -1, pi. We're right there. Connect the dots, make them wavy again. Notice here that the function is going down, just like cosine goes down there, so it makes sense that it's traveling downwards. And that's it for inverse cosine and inverse sine. I hope this made sense. It can be tough at first for sure, but once you understand it, you'll be set. So let me rewrite the domain. Is from -1 to 1. Range is from 0 to pi. So know those attributes and you'll be fine. Thanks for watching.